Okay, and welcome to the next video where we're going to look at the quantities and units that we use in mechanics in order to understand exactly with each quantity how does that link to each sort of concept in mechanics and make sure that we do the correct thing. So let's get into it. So this table is in the mechanics booklet, and it sort of clearly puts out everything in terms of the symbols, units and conversions. Okay, so quantities are represented by a value and a unit. So 3 kilometers, that's the value, that's a unit. -7 newtons, 0.72 meters per second. SI units is an international system of units. Okay, it's agreed on throughout the world to use these units to represent time. To represent these concepts. Okay, so if we have the concept of time, the symbol given to that is normally a lowercase t, and the SI unit is seconds. Okay, so S, which represents seconds. Force is given by the symbol capital F, and the SI unit for that is newtons with a capital N. Mass is given with the symbol lowercase m and a unit of kilograms. Weight is given by a symbol of W and a unit of newtons as well. Weight is also a force. Okay, you have to understand that mass and weight are completely different concepts. Length is given by the symbol S and a unit of m. Velocity is given by the symbol of U and a unit of meters per second. Acceleration is given by a symbol of A and a unit meters per second squared. Acceleration due to gravity is given by a symbol G and the unit is 9.8 meters per second squared. It's a type of it is acceleration, but it's due to gravity. And obviously here are the conversions that these are it's just common knowledge really. So why is this really important? Well, first of all, throughout the mechanics course you need to know these units. Okay, and you need to make sure that you write them at the end of each answer. So if you've got a question which is asking for, the mass of an object, you do a few calculations, you have to write kilograms next to it. Similarly, if they ask you for acceleration, you have to write meters per second. Where do things get a bit tricky though? Well, where we have to write things in SI units which are not originally in SI units. So SI units, remember, seconds, newtons, kilograms, newtons, meters per second, all this sort of stuff here. So let's just have a look at this and think about how we would convert these to SI units, standard units. So I've got 5 kilometers. Kilometers, if you look at the units, we know that kilometer is a length, but the standard or the SI unit for length is meters, not kilometers. So this is just common knowledge. 5,000 meters would be the correct conversion. So 5 kilometers, you need to convert that into 5,000 meters in mechanics. Okay, so with part B, what we've got is we've got 0.73 grams. So we've got to convert that into appropriate units. Now, if you look at the table, we know that grams is associated with mass. The SI unit for mass is kilograms, not grams, so we need to convert from grams to kilograms. We do that by dividing by 1,000. When you do that in a calculator, you get 7.3 times 10 to the minus 4 kilograms. Okay, right, part C, 4.5 minutes. Now we know that's to do with time, but the standard unit for time is not minutes, it's seconds, so we need to do 4.5 times 60 seconds, and when you do that you get 270 seconds. So be aware, if you have any mechanics questions that deal with minutes, you've got to convert them into seconds. Now from D to G things are going to get a bit tricky because we've got a couple of units, and in A to C we had just one unit that we had to convert to SI. Here we're going to have 2. So we've got this one here, 25 centimeters per minute. Now clearly this is to do with velocity, and velocity is meters per second. So to think about this carefully, 25 centimeters per minute, and then we have to go to meters per second. So that's the aim. So what I advise you to do is think, okay, let's deal with the 25 centimeters first. Let's think about how many meters that would be. Okay, so 25 centimeters, that would be 0.25 of a meter. So that's a good start. That's something that we can do. Just do 25 divided by 100, 0.25 meter, and then you've got to think, okay, so it's 0.25 meters over a minute. So 0.25 meters over a minute, that means if you divide by 60, you get the meters per second. Yeah, we know the meters per minute. Divide by 60, you get the meters per second, which is 4.17, 3 SF, times 10 to the minus 3 meters per second. Okay, so be aware of that sort of thing. Okay, we've got to convert not only the centimeters but the minutes as well to seconds. Okay, right, so 4.5 minutes. Okay, and we've got E. So with E, we've got 8.2 times 10 cubed kilometers per hour. So 8.2 times 10 cubed kilometers per hour. Now, 8.2 times 10 cubed. If you think about that, that is 8,200 kilometers per hour. Now you have to be careful here because if we're dealing with distance with time in this manner, the ratio of distance to time, then obviously it's another velocity situation. So what we've got to deal with here is not only converting the kilometers to meters, but also thinking about how we're going to change that into meters per second instead of kilometers per hour. So 8,200 kilometers, and that is going to be, if you times that by 1,000, that will tell you how many meters that's going to be. Okay, it's going to be 8. Okay, so there we have it, or we can write that in standard form. So we had 8.2 times 10 cubed times 1,000. So 8.2 times 10 cubed. I think it's 10. Yep. So we're going to 8.2 times 10 cubed times 10 cubed, because 1,000 is 10 cubed. Yep, so it's going to be 8.2 times 10 to the power 6 meters per hour. Okay, it's going to be 8.2 times 10 to the power 6 meters per hour. And obviously we don't want meters per hour, we want meters per second. Now, we've got to think about this very carefully. 8.2 times 10 to the power 6 meters, and per hour, you then will have to divide by how many seconds there are in an hour. Now, obviously, in 1 hour you've got 60 minutes, and the amount of seconds in that will be 60 times 60. Okay, so it's going to be, you've got to divide that by 60 times 60 seconds, and that will give you the meters per second. Right, so 60 times 60, 8.2 times 10 to the power 6 divided by 60 times 60, and that will give you 2277.8 meters per second. Okay, so there's our answer for E. And again, just if you break that down, does that work? If that's meters per second, then times it by 60, that'll give you meters per minute. Then times it by 60 again, that will give you meters per hour, which is correct. Okay. Then we've got F and G. I'm going to turn over the bit of paper. So you've got F and G, 45 grams per meter cubed. Okay, so 45 grams per meter cubed. Again, the grams is not the SI unit for mass, so we need to change the grams to kilograms. Meters cubed, that's fine, we can have that, so that's not an issue there. So we need to change the 45 grams to kilograms. So 45 grams is obviously going to be, we've got divided by 1,000. So 45 divided by 1,000 is going to be 0.045 kilograms. So the final answer will be 0.045 kilograms per meter cubed. Okay. Right. Now we're going on to the final question, which is G. Okay. And what we've got here is 45 grams per centimeter cubed. Right, so there's two things we need to consider here. We've got the grams, which we need to consider to kilograms. Centimeter cubed, we need to get that into meters cubed. So first of all, we know that the 45 grams divided by 1,000 will give us a 0.045 kilograms. But we need to then realise that's 0.045 kilograms per centimeter cubed, which we need to consider what would that be in terms of meters cubed. Right, now you've got to think about this very carefully. What is this situation as such? So if you look at F, 45 grams per meter cubed. So 45 grams per meter cubed, we had so grams per meter squared is all about density. Okay, so we've got to think carefully about this. 45 grams per meters cubed is here, so that's the density of a material, let's say. But when you've got centimeters cubed, how would I convert that into meters cubed? So imagine, what is a centimeter cubed? A centimeter cubed looks like this: 1 centimeter, 1 centimeter, 1 centimeter. Now, in terms of thinking about that in terms of meters cubed, 1 centimeter is 0.01 of a meter. So to get the answer in terms of meters cubed, we've got to understand 1 centimeter cubed is the same as 0.01 meter cubed, or 0.01 cubed, yeah? Same as that. So in terms of our final answer, 0.045 divided by 0.01 cubed, yeah, that will give us our answer in terms of kilograms and meters cubed. So 0.045 divided by 0.01 power 3, what you get is 45,000 kilograms per meters cubed. Okay, so slightly trickier. This is more of a density situation, but again, it's all about thinking about the units at a much more deeper level. Okay, so again, if we think about what we did with the speed, the distance, and thinking about how I'm going to get them to SI units, very important skill. So here are the questions on the bottom of the page, which you could use to help you out in terms of doing more practice. That's the end of the video.